Hello everyone, I am Alkush. In this video, we will solve one problem from chapter 21. The below figure shows 3-point charges fixed on a coordinate system. Find the net force produced by charges Q1 and Q3 on charge Q2 in unit vector notation. The charges are Q1 equals 3 nanocoulombs, Q2 with negative 2 nanocoulombs, and Q3 with negative 5 nanocoulombs. First, for symbolic solution, let us call 1 nanocoulombs as Q, which is 1 times 10 to negative 9 coulombs. Q1 is 3 nanocoulombs, then it is 3Q. Q2 is negative 2 nanocoulombs, then it is negative 2Q. And Q3 is negative 5 nanocoulombs, then it is negative 5Q. Also, let us call 10 centimeters as R. In SI unit, it is 0.1 meters. After that, the distance between Q2 and Q3, that is R23, becomes 5R. And the distance between Q1 and Q3, say R13, becomes 3R. Lastly, the distance between Q1 and Q2 is found by the Pythagorean theorem as R12 equals square root of 3R squared plus 5R squared, which gives square root of 34R. Okay, we can solve the problem. The force on charge 2 produced by charge 1 is K times absolute value of Q1 times absolute value of Q2 over R12 squared. The absolute value of Q1 is 3Q and the absolute value of Q2 is 2Q. R12 squared is 34R squared. Here 34 is simplified by 2. Then F21 is obtained as 3 over 17 times KQ squared over R squared. For symbolic solution, let us call K times Q squared over R squared as F. Then F21 becomes 3 over 17 F, where F is calculated as 8.99 times 10 to negative 7 newtons. In order to find the direction of F21, we note that Q1 is a positive charge, Q2 is a negative charge, then the direction of F21 is from Q2 to Q1. If we call the corresponding angle as alpha, the direction of F21 is obtained as cosine alpha negative I hat plus sine alpha positive j hat. From the figure, sine alpha is 3 over square root of 34. Cosine alpha is 5 over square root of 34. If we write these values, we get the direction as negative 5 over square root of 34 I hat plus 3 over square root of 34 j hat. Finally, in a compact form, F21 vector can be expressed as F times negative 15 over 17 square root of 34 I hat plus 9 over 17 square root of 34 j hat. Finally, the magnitude of the force on charge 2 produced by charge 3 is K times absolute value of Q2 times absolute value of Q3 over R23 squared. With the corresponding expressions, the magnitude of F23 can be written as 2 over 5 times k times q squared over r squared. As you remember, k times q squared over r squared is called f. So f23 has the magnitude of 2 over 5 f. The direction of f23 is found as follows. q2 is a negative charge, so is q3. So there is a repulsive force between them. Then f23 is to the right. As a result, the vector f23 is 2 over 5 f I hat. The net force on q2 produced by charges q1 and q3 is the vectorial sum of the forces f21 and f23. Then we can substitute their values into this equation. The x component is f times 2 over 5 minus 15 over 17 square root of 34. And the y component is f times 9 over 17 square root of 34. Because f is 8.99 times 10 to negative 7 newtons, the calculation gives us the net force produced by charges q1 and q3 on charge q2 in unit vector notation as approximately 2.24 I hat plus 0.816 j hat times 10 to negative 7 in newtons. If we draw the xy coordinate system, the direction of this force is in the first region, that is, positive x and positive y region. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you on the next video.